Now we are going to talk about the rationalization. So in the this lectures is relating the concept of rationalization and why we need that. That is going to be a conjugate. Here we are going to use conjugate extensively. Okay, so first let me explain with the first example, that is limit x tends to 0 and the question is square root of 1 plus x minus 1 divided by x. So if we put this limit x tends to 0 in the inside the square root, this is going to be 0 and only 1 is there inside the square root. So if that will be equal to 1 because inside the square root there is only 1 is there. So 1 minus 1 is going to 0. In numerator what we have 0, and if we talk about denominator we have again 0 by 0 form. This is we can recognize, we can use this form for solving these types of limits. We can use the L'Hopital's rule because this is indeterminate form, and we know the L'Hopital's rule we can use for 0 by 0 form, infinity by infinity form. So yeah, this is what the indeterminate form. Indeterminate form, yes. And the let me write it again. Limit x tends to 0. This is 1 plus x minus 1 upon x. Let me change the color so that would be easy to understand. Let me try to multiply with the conjugate of this numerator, because we can see here, if we multiply the numerator with the conjugate we can remove the this square root, and after that if it is removed then we can cancel out the term 1 and 1, and again x would be cancelled in the next step. Let me show you how we can do that. So 1 plus x plus 1 divided by square root of 1 plus x plus 1. So if we multiply, we know that the concept of a square minus b square. Yes, in the first round bracket we have a plus b, and in second round bracket we have a minus b. So I'm using the same formula here. So what we have, that is limit x tends to 0, and finally we have 1 plus x minus 1, and in denominator we have x, and inside the round bracket we have a square root of 1 plus x plus 1. So let me show you, like minus 1 is here and plus 1 is here. We can cancel out this term. So we're gonna cancel out the term x and x. And after cancelling the 1 and minus 1, we can see the remaining numerator. There is only the x terms, and denominator we have x in multiple of the square root of 1 plus x plus 1. Yes, so we can cancel out the term x. So what we have remaining 1 upon square root of 1 plus x plus 1. Yes, so if we put x is equal to 0 in the square root, what we have, because this is not false in the indeterminate form, now we can put the limits value and we can solve these limits. So x tends to 0, then this is going to be 0 and 0, and inside the square root there is only 1, so that would be equal to 1, and 1 plus 1 is going to, here is 1, here is 1, that is equal to 1 by 2. This is going to be answer for this limit.